Now let's show that it is a permutation group. So here's our front and back figures. In our permutation group, so here's the element that we had that correspond to their moves. For p sub 0, meaning do nothing. For p sub 1, meaning rotate 45 degrees counterclockwise. For p sub 2, meaning rotate 90 degrees counterclockwise. P sub 3, rotate 135 degrees counterclockwise. P sub 4, rotate 180 degrees counterclockwise. P sub 5, rotate 225 degrees counterclockwise. For P sub 6, rotate 270 degrees counterclockwise. For P sub 7, rotate 315 counterclockwise. For mu sub 0, we are going to flip about vertical line. Mu sub 1, meaning flip between vertical line and first left diagonal. For mu sub 2, flip about first left diagonal. For mu sub 3, flip between first diagonal and horizontal line. Mu sub 4, flip about horizontal line rather. For mu sub 5, flip between first right diagonal and horizontal line. For mu sub 6, flip above first right diagonal. And lastly, for mu sub 7, we will flip between vertical line and right diagonal. So here's are the result for each element we had. In here, it shows how the table being operated with the p sub 0 to p sub 7 and to mu sub 0 to mu sub 7. After operating all the elements, so here is our final result in our table. Now let's check if this is a permutation group. So what we need to confirm it is a close, associative, it has a identity element and an inverse element. So let's check first if this is a close. As you can see, this table is closed, where all elements stay within the sets. Now, let's check for its associativity. So what we need to do is rotate the table by 180 degrees and interchange the rows and columns if possible to get the same result in our just like in our original table. So as you can see, it is already rotated by 180 degrees. So what we need to do is to interchange the columns para makuha na natin yung associativity na to and para ma-check natin kung associative nga ba talaga siya. Given the final result, we have confirmed that it is also a associative. Now, let's move on to identity element. So we can conclude that P sub 0 is the identity element of this binary structure, where all elements that will be operated with P sub 0 will be the result itself. Now, let's check if this this table is or has an inverse element. Now we have confirmed that there is an existence of inverse element. So each element of P has its own inverse element. Like P sub 0 inverse niya is equal to P sub 0. P sub 1 inverse is equal to P sub 1. P sub 2 inverse is equal to P sub 2. P sub 3 inverse is equal to P sub 3. P P sub 4 inverse is equal to P sub 4. P sub 5 inverse is equal to P sub 5. P sub 6 inverse is equal to P sub 5, and so on and so forth. Since all elements of P has its own inverse, it satisfies the inverse element. So it is closure, associative, identity element, inverse element. So therefore, this forms a permutation group.